Welcome to my presentation on heating up efficiency, exploring heat pump options in Pennsylvania. As we go through today, just as a reminder, this session is approved for one AIA LUHSW credit. As you may have read while you were registering, this is the webinar's description. Today, I will be discussing information that is related to heat pump options in Pennsylvania for heating and cooling in residential construction. I will be sharing the different types of systems and any information regarding them, installation, considerations, and design best practices and potential challenges as well. These are the learning objectives for the webinar, which will be incorporated throughout the presentation as well. And before I continue, I just want to clarify that this presentation is educational in nature. We're not promoting any specific product or method. It's important that systems and materials are selected based on the needs of the designed assembly. So diving into it, types of heat pumps. There are four main types of heat pumps that we will touch on today. They are the air source, air to water, ground source, and dual fuel systems or hybrid systems. Your air source is the most widely used type, where it pulls heat from the outdoor air and transfers it indoors during the winter and reserves in the summer for the cooling. Air to water systems transfer heat into water instead of air, making them ideal for radiant floor systems, radiators, or baseboard heat. Ground source or water source, often called the geothermal systems, utilize the relatively stable temperatures underground or in water bodies for high efficiency heating and cooling. And then you have the dual fuel or the hybrid systems. They pair a heat pump with a traditional furnace, automatically switching between the two based on outdoor temperatures to maximize efficiency. So the next couple slides, we're going to break each system down in more detail. Starting off with the air source. This is the most common type of heat pump, and these systems work by transferring heat between the air and outdoor, or the indoor and outdoor air. In the summer, they pull heat from inside your home and move it to the outside. In the winter, they do the opposite, extracting heat from the outside air and bringing it in even when it's cold. Air source heat pumps are widely used because of their relatively low upfront cost compared to other systems, and they're easier to install in most existing homes as well. However, regular maintenance such as checking filters, refrigerant levels, and system components is very important to keep them operating efficiently and to extend their lifespan. This type of system is versatile and efficient for many homes in Pennsylvania, especially as technology continues to improve cold weather performance. The next one are air source ductless. So it's still the air source world, basically, that type of system, but this is your ductless system. This is commonly referred to as the mini split systems. There's typically an outdoor unit connected to an indoor unit. You can have wall mounted, where it's mounted higher on the wall, typically near the ceiling. In the space they are designed to heat or cool. You can also have a ceiling cassette. These offer, you can recess them in the ceiling, providing a more discreet and obstructed look while effectively distributing the air inside the space. But the biggest issue with that is you need to be sure there is enough space in the ceiling for the unit plus any insulation above as prescribed by code. And then you have a floor mounted, which is installed near the floor, typically installed in rooms where wall or ceiling space can be limited. It could be a good solution for older homes or possibly in basements as well. And then you have the concealed duct. This is hidden within the ceiling or wall with only grills or diffusers visible, often paired with short lengths of ductwork to be distributed or to distribute the air to multiple registers, similar to a ducted system, but it is a little bit different. Along with this, it offers zone controlling. So zone control, each indoor unit can provide independent temperature control for different rooms or zones. For example, you could have a mini split in your dining room and then a mini split in your living room. And maybe you don't use the dining room quite as much as you do the living room. So you could have the mini split in the dining room set at possibly 65 degrees in the winter, where maybe in your living room you want that set at 73, keeping it a little more comfortable, little bit warmer. So it offers the zone controlling as well. It can improve the comfort and it can also help save energy as well. And there are some mini split units that can allow for multi-zone features off, you have multiple indoor units off of one outdoor unit. And then you have the cold climate heat pumps. These are designed to perform in temperatures as low as 5 degrees. You want to look for a system that is labeled with an Energy Star cold compliant or cold climate label on it. Then we have the air source ducted. This is commonly known as our central or forced air system. With these systems, you have extensive duct work that needs to be installed, moving the air from a handler to different areas of the home, as well as returning air back to the handler as well. There's a lot more prior planning that's required for this type of system. So it's not as simple as with the last one that we spoke about, the ductless, the mini split, where there's no ducts required. With this one, you have to plan where where the ducts will run, and how you will get from point A to point B inside the home. When you're adding an addition onto the home, there's planning that needs to take place to connect installed ductwork, which is very, very important. Sizing for these systems is essential, especially for the ducts, to be sure the proper volume of air is being moved to properly heat as well as cool the home. And then we move on to the air to water system. This is a less common but highly effective heat pump option. It's the air to water system. It's a ductless option. And it's important to note it provides heating only, not cooling. So unlike traditional air-based systems that use the forced air, this system heats water, which is then distributed through the home for comfort. That water can be distributed through in-floor radiant heat systems. It could be baseboard heating units or traditional radiators that you find in older homes as well. These systems, they're ideal for homes that already may have those baseboard heaters, the hydronic heating infrastructure, as we call it, or the radiators. It could be a good solution to switch over. But like I stated before, the biggest downfall to them is it is heating only. And there's no cooling that goes along with it. And then we have our ground source heat pumps. This is commonly referred to as our geothermal systems, you might hear them called. These take advantage of the Earth's stable temperature to heat and cool the home. They're categorized, you can have a closed or an open loop. They're installed horizontally, vertically, or in a pond or a lake. That's where they bring the heating from the Earth's stable temperature into the home. So the type that you would use would depend upon the land that's available, where the home is being built, whether it's soil or rocky type of ground at installation as well, because that's going to dictate what you might use. So a little background on it. A closed loop, that is a water refrigerant based. It's either circulated through pipes or tubes underground, collecting heat from the earth and carrying it through the system and into the building. In the summer, it reverses, pulling heat from the building and placing it in the ground. It's a little bit more expensive to install due to installation requirements, however, more efficient if done correctly. The open loop, it's the same basic principle as the closed loop operation. However, this needs to be installed where an adequate water supply is available and you have open discharge. So the open loop, it's pulling water in, but then it's discharging as well. The benefits are similar to your closed loop system. It can be a little less expensive than the closed loop, but in some cases, or most cases, more energy is needed to pump water through the system. Also, as I said before, it needs that good water supply and a safe discharge, which can be a challenge at times. You might not be able to get that, especially in our summer months when sometimes it stops raining and it gets dry. And then with the closed loop as well as the open loop, you can have trenches. These are your horizontal loops. So they'll dig down typically 5 to 6 foot. and they bury the piping in trenches. And typically with this one, there's more piping that's going to be required during installation. This might be your more expensive type because you've got more excavating that you have to do with digging the trenches. There's more labor involved with laying them. Uh, However, when you do the vertical loops, which is your wells, which is the other option with the closed loop system as well, then you need to bring in a well driller to drill those wells. They put deep vertical wells into the ground. And so sometimes they might equal out in price, but the trenches and the wells they're almost the same. However, with the wells, less piping may be required. You might not need as much piping. And the advantage to the wells over the trenches could be you're down deeper in the soil, whereas trenches, you're closer to the ground level. And if you have a dry summer and the ground starts to dry out, that heat could actually start to penetrate down in closer to your trenches, to your piping as well. So with these systems, there is a greater upfront cost to installation, but the data is proving that over time they do save money as they are more efficient. The other thing that could run with these, additional permits might be required depending on the location for running the in-ground loops. So it's always a good idea to check with local zoning requirements to see what is required in that municipality or area. And then we have our dual fuel or hybrid systems. So these systems, they combine the efficiency of the heat pump with the reliability of a gas furnace. They're made up of both an electric heat pump and it could be a gas furnace or propane. It all depends on what it is. They work together based on the type of comfort to help maximize efficiency and effectively heat and cool the home year round. So these are commonly found in the Mid-Atlantic region, mostly because our temperatures in the winter, due to the Pennsylvania climate, could get a little bit chillier. So when it gets colder, the supplemental heat, the dual fuel or the gas furnace can take over, and then the heat pump runs during the milder temperatures, which helps make them a little more energy efficient systems that you can use. Some advanced heat pump technologies, these have been introduced over the years, making heat pumps even more and more energy efficient. And I'm sure as time goes on, there's going to be more as we move down the road too. So the first one there, the staged or multi-speed compressors, they let heat pumps operate close to the heating or cooling capacity needed at any outdoor temperature. They save energy by reducing on or off operation and compressor wear. Their inverter-driven systems can modulate their speed capacity at near infinite degrees as well, between low and high settings, running more efficiently and maintaining consistent comfort. Inverters, a little background on them. They were introduced about 25 to 30 years ago. Previous to the introduction of the inverters, heat pumps didn't work when temps would drop below 35 degrees, making a heat pump not a very good system in this area. So a little history lesson for you. Variable speed or dual speed motors. A lot of newer models of heat pumps and furnace blowers are equipped with electrically commutated motors or ECMs, or variable speed or dual speed motors on their indoor fans, outdoor fans, or both even. These variable speed controls for the fans, they keep the air moving at a more comfortable velocity. They're minimizing cool drafts. They help maximize electrical savings, and they help reduce noise and disruption as well. And then there's the D superheater. These are some high efficiency heat pumps. They're equipped with a de-superheater, which recovers waste heat from the heat pump's cooling mode and uses it to heat water. These heat pumps can heat water 2 to 3 times more efficiently than an ordinary electric resistance water heater. So they can be used, in many cases, you don't have an electric hot water heater. Your hot water heater also works off of your heat pump due to this technology. And then the dual fuel or hybrid systems, we spoke about them before. That is an advanced heat pump technology. It combines the efficiency of the heat pump with the reliability of a gas furnace. That combination does allow the heat pump to handle most of the heating, like I'd stated before, during milder weather or milder winters, where the furnace will take over when the temperatures do dip and get colder. So how it works, energy efficiency during warmer months, the heat pump efficiently cools or heats and cools the home. When the temperatures drop, the system automatically switches to the gas furnace, which is better suited for colder weather. And then also we have cold climate heat pumps. These are designed to perform in temperatures as low as 5 degrees. Like I'd stated before, regions where temperatures regularly dip below freezing in winter months, these could be a good option. You want to look for systems that are labeled as an Energy Star cold climate label. Some climate sustainability discussions here. Let's look into this. So knowing the climate zone where you are that's key, as it's going to help you to identify the proper equipment that you need. This map that you see on your screen there, I pulled that from the 2021 IECC and 2021 PAUCC codes. So it shows there are 8 distinct zones, climate zones, and those zones are labeled as zones 1 through 4 are commonly known as your cooling climates. Climate zones 5 through 8 are considered your heating climates, is how they break them down. If you notice, Pennsylvania, we have two zones in our state. We have climate zones 4 and climate zones 5. So climate zone 4, that falls into the cooling climate zone. However, we all know the southeast corner of the state can get pretty cold in the winter as well. So you still want to keep that in mind when you're planning what type of heat pump system or heating system you're going to put in the home. Understanding the heat pump that you're installing or you're designing for is going to be very essential. Be sure to check manufacturer specifications to be sure the system will work best in the climate zone that the home is being built in as well. So the Pennsylvania climate, we experience 4 distinct seasons, making Pennsylvania a pretty nice state to live in. Primarily, it has a humid continental climate, or what's considered a warm, hot, humid summer and cold winters is what we end up having. Topographical changes can influence differences in weather and climate. Paying attention to the area the home will be built is key and essential as well. If you're building the house and it sits high up on top of a hill where it's kind of open, it doesn't have much breaking the wind. In the wintertime, it can get pretty cold inside that home. So keeping in mind the southeastern portion of the state, a lot of times, typically, they'll have somewhat milder winters and hotter summers due to its elevation and proximity to the coast as well. That'll play a factor. The Northwest can see significantly more snowfall in the winter, as well as experience colder temperatures too. So some weather data over the last 2 decades, it's showing an increase in cooling degree days for Pennsylvania and fewer heating degree days. The data shows the temps have increased 1.8 degrees Fahrenheit in the last century, and they're expecting the temperatures to warm another 5.9 degrees by 2050 as well. Some interesting information for you there. They also state that we may see more days above 90 degrees Fahrenheit by mid-century compared to the year 2000. So all of this plays into part with choosing the proper system. You want to choose the system based on the climate, the area the house is going, look at all your different options as well. So you have a good system that will cool properly in the summer and it'll heat properly in the winter. Moving along with that, sustainability. So heat pumps are considered sustainable because they efficiently transfer heat rather than generating it. They use much less energy and significantly reduce carbon emissions compared to fossil fuel-based systems. They can also be powered by renewable electricity sources like solar or wind, further maximizing their sustainability as well. Studies are showing more people are installing self-contained solar power systems that are helping to run the heat pumps that are installed. They can also buy electric from suppliers that are creating it from renewable sources. Some different types like the air source Ground source and water source offer various levels of efficiency, depending on the climate and application, with ground source, geothermal often being the most efficient, known for exceptional efficiency. Uh, they also harness renewable ambient heat from the environment, whether it's air or ground, and use electricity to convert it into heating or cooling, making a more efficient system than those that burn fossil fuels. So some of the renewal components as well, the heat source from from the heat pump, ground or air is considered renewable. So that helps it fall into that category. Electricity to power the pump's compressor is crucial. If the electricity is generated from fossil fuels, the heat pump's overall carbon footprint is considered to be higher. It's not truly renewable, but like I stated before, it all depends on where that electricity is coming from. And there are more and more electricity generators or suppliers that are getting it from renewable sources. So a couple other things to point out here is policy recognition. Many government and industry bodies recognize heat pumps as a key component for transitioning away from fossil fuels and having policies to support their adoption as well. Moving along. Ooh, energy efficiency. Let's talk a little bit about energy efficiency here. Some different ratings so you understand when you see these, what they mean. When we talk about energy efficiency in heat pumps, we're really referring to how much heating or cooling the system provides compared to how much energy it consumes. Because heat pumps move heat rather than they generate it, they're inherently more efficient than traditional systems like a furnace. So with that, they recognize the first one there, the coefficient of performance, or COP. This is the ratio of heat output to electrical energy input. A higher COP means better efficiency. For example, a heat pump with a COP of 4 provides 4 units of heat for every 1 unit of electricity consumed. And then moving on there, we've got the energy efficiency ratio. This is the EER. The EER is primarily used for cooling performance. If it's the system's cooling output in BTUs per hour divided by power consumption in watts. Again, the higher EER, the more efficient the system is at cooling in a controlled environment. And then we have our seasonal energy efficiency ratio, or a SEER. The SEER evaluates cooling efficiency over an entire season, taking variable conditions into account. So a standard SEER ratio will fall between 13 and 16, while a high efficiency system has a ratio or a rating above 16 is what you want to look for. And then you've got the heating seasonal performance factor, or the HSPF. This measures heating efficiency over the full season. It's the ratio of total heat output to electricity that was used, measured in watt hours. So a standard HSPF is typically between 8 and 10, with high efficiency defined as greater than 10 is what we have. And then we have what's new is the SEER2 and the HSPF2. So beginning in 2023, the Department of Energy introduced SEER2 and HSPF2 to better reflect real world performance, accounting for external static pressure and the system installation variables. So these updated ratings, they require a more rigorous testing, meaning the numbers may appear lower, but the systems themselves are not less efficient. So when you're thinking of SEER2 and HSPF2 as more accurate versions of the original ratings, think of them as they're helping us to better understand how systems will actually perform in the homes, not just in the lab. So right now we're still in a transition period with these. So you may still see equipment listed with just SEER and HSPF, but SEER2 and HSPF2 are becoming the new norm. So you'll be seeing them a lot more. The biggest thing here is understanding these ratios is crucial when you're evaluating or specifying a heat pump system that you're going to use in a home. They help us to compare models, justify the investment decisions, and ultimately ensure that we're recommending systems that meet both efficiency goals and the homeowner comfort needs that are important. So some performance factors of the heat pump systems you need to also take into consideration. There's a number of key items here, such as climate, sizing, proper installation, and insulation and home envelope. So when you're talking about or dealing with the climate and weather conditions, efficiency is greatly impacted by the climate. The air source are, or an air source system are typically more effective in milder climates, as extreme temperatures can reduce their efficiency. Your ground source, geothermal, may maintain higher efficiency regardless of air temperature because they are exchanging heat from the ground to the home, which remains at a more constant temperature. And then when you're looking at sizing, with heat pump size and sizing, choosing the correct size for the heat pump is extremely critical. The importance of having an HVAC professional size the unit is extremely crucial because they are the professional in this and they understand what they're doing. If you install an undersized unit, it's not going to adequately heat or cool the home, which will lead to an increased energy consumption. And if you install an oversized unit, it's going to cycle on and off more frequently, causing unnecessary wear or reducing the efficiency as well. So getting those detailed calculations is very, very important with getting the proper sizing, looking at the home's square footage, the layout, heat loss characteristics, all of those different areas. And then when you're talking about proper installation, so installing the system and the ductwork is extremely important as well. Proper installation by a certified HVAC professional is important. That helps to ensure optimal performance and the longevity of the heat pump. And well-designed and sealed ductwork is critical as well for the efficiency of the air distribution. It minimizes losses that occur through leaks or inadequate insulation as well. And then last there, the insulation in the home envelope is extremely important. Adequate insulation and a tight home envelope are key to maximizing the heat pump efficiency as well. That also helps retain conditioned air, reducing the load on the system. Having a well-insulated home will result in less energy to maintain the comfortable temperatures, enhancing both the cooling and the heating efficiencies down the road. So how does a heat pump work? We already stated, or I already talked about heat pumps. They don't generate heat the way a furnace does. Instead, it transfers heat from one place to another. This can be heat from the outside air, the ground, nearby water, or even waste heat from industrial sources as well. It operates much like a refrigerator or an air conditioner. It uses a compressor and heat exchangers to move a refrigerant through a cycle that extracts and then distributes the heat because it's mostly just transferring heat. It's using much less energy than traditional heating systems like boilers or electrical heaters or electric heaters. In fact, for every unit of electricity used, a typical residential heat pump can deliver about 4 units of heat. That's a coefficient of performance or a COP of 4, making it 3 to 5 times more efficient than a standard gas boiler, is what the data shows. So the heat pump delivery methods, they can be optional to a point. So heat can be delivered by forced air, radiators, baseboard units, or underfloor heating as well. Cooling, you're kind of limited there, where cooling can only be delivered by forced air application. Heat pumps can be connected to a tank, providing sanitary hot water for use in the home as well. So they can be connected to a hot water heater, or essentially they can provide the hot water heating for the home. So that can be an energy saving feature, as you can reduce the cost of operating a hot water heater. We all know hot water heaters take a lot of electricity to run, especially your electric ones. Due to the flexibility of heat pumps, they work in reverse during the summer to provide cooling. So they can provide both heating and the cooling. And then you have the common or the combined, you can combine them with other systems, making them the hybrid or a dual fuel system. combining that heat pump with a gas furnace, which could be a good setup for a home. So some benefits of a heat pump. Let's look at some cost factors. So we'll talk about some costs associated with installing a heat pump. In general, what I found is installation, it can range anywhere from $6,000 to $25,000 or more, depending on a whole variety of factors. It's a huge range, and this often surprises homeowners when you share that cost number with them. It's important to help them to understand where their specific price point may fall. So some of the biggest variables that can affect this price, number one is the local market, the labor rates for the area, equipment availability can vary widely, especially across Pennsylvania and beyond in other states as well. The condition of the home. Older homes, if this is a retrofit or renovation, older homes may require additional upgrades like electrical service updates, insulation improvements might need to happen, or even there could be, you might be looking at asbestos abatement, any of that may fall into place with it. And of course, the climate is another cost consideration. Colder areas might require cold climate rated heat pumps, or it might require backup systems, which can increase the cost. When we break it down further, the key factors that influence cost is the size of the home. Larger homes require larger or multiple systems. You've got the type of heat pump. So the type of heat pump selected, whether it's air source, ground source, mini split, dual fuel system, they all come with different price tags as well. Regional climate affects what equipment is needed. For example, homes in northern Pennsylvania may need higher capacity units. So the state of existing ductwork as well, if it's outdated or it's even missing, that adds to installation time and material costs. And finally, installation labor. Skilled labor costs vary by region and are influenced by local demand, especially with the recent growth in electrification and energy efficiency upgrades. So when homeowners ask, why is this so expensive? It's helpful to explain that these systems are both an HVAC upgrade and an energy investment. And when properly sized and installed, they do offer long-term savings that often offset that upfront cost. So some compatibility and energy savings here. When we're looking at retrofits or renovations, installing a heat pump system, even when a gas furnace may already be installed, could be the best solution. So mini splits, they offer flexibility in installation. No ductwork is needed. With a mini split, you can also install multi-zone mini split systems. In a lot of cases, if you do a multi-zone mini split system, it can go up to 8 zones per outdoor unit. So an option could be leaving the gas furnace as a backup heat for colder temperatures in the winter. Maybe there's nothing wrong with that gas furnace, so you let it there and it offers supplemental heat for them. Installing the heat pump or a heat pump conditions the home with heating and cooling capacity for the summer or warmer months. The energy savings potential, as you can see from the chart, so I put a chart. This chart was found, it's data that was posted by the U.S. Department of Energy. They posted this on February 14th of 2024, so not too long ago they posted it. It shows the savings when installing a heat pump system in a home that had systems fueled with fuel oil, propane, electric, non-heat pump. So that's just basically electric baseboard and or natural gas. There's a savings on all upgraded systems, showing the potential to be a cost saver to homeowners. So like, for example, if you look at that chart, the fuel oil at the top, so that would be a home that had a system that was being run by fuel oil, and they're showing with installing the heat pump, that was their savings, anywhere from, you figure, $900 to $2,800. Some other things that go along with it is tax credits. So homeowners can still take advantage of tax credits from the federal government until the end of this year. That does run out. The data shows it runs out December 31st, 2025. So that's a 30% of the cost up to $2,000 annually on qualifying heat pumps. I have not been able to find any evidence that they're going to continue this incentive or replace it with another, but as we always know, the government, they're usually coming out with incentives. So just keep a track, keep checking on your tax credits or any other governmental programs for this. Flexibility. When you're considering or looking at flexibility of a heat pump, with the heat pump options, there's a few areas that stand out the most. Traditional mini splits, no ductwork is needed, so you don't need to install the ductwork. They offer a great deal of flexibility when you don't need the ductwork, especially older homes, retrofits. All you need is an interior location as well as an exterior location for the units to be installed. Uh, and both have ease of access to each of them. And then ducted heat pumps, they can be a great option when installing the system in a home that already has ductwork installed. You want to be sure to check the existing ductwork, replace as needed or upgrade if larger is required. It's a good idea to do calculations and make sure the existing ductwork is up to capacity. And then some long-term options to consider. The data has proven a ground source system, when it's installed properly, can be operational for many years. In most cases, 25 plus years with typical maintenance and repairs. The geothermal systems have been proven to be the most energy efficient, uh, but they can be the most costly though. So there's a lot more upfront cost with them. However, they could pay off in the long term. Some long-term energy savings. There's a number of factors involved with this. First of all, new construction versus existing construction. Completing proper calculations of the new or existing structure is key to planning the best system for the best savings. So there might be some more upfront costs in some cases to install the system, but in the end, overall, the cost savings will save them money down the road. And then proper planning. Consider the home design and building envelope when selecting a system. You also want to consider climate considerations, uh, where it's sitting, where the home is, what the climate looks like. Local energy costs. Are there any renewable energy sources available? Could solar be installed on the property as an energy source for powering the system? And then look at home efficiency. Is the home insulated properly? What type or condition are the windows and doors in? Let's face it, if the windows and doors are leaky, you can have all the insulation in the world, but you're still going to have air infiltration. Good building envelope is very, very important when you're looking at the big picture of all this. And then finally, look at incentives and rebates. Check the government programs or local incentives and see if there's anything out there to help the homeowner out when selecting a system. Some other things to consider: emissions and carbon footprint. So one of the major reasons we're seeing increased interest in heat pumps, especially in Pennsylvania, is the environmental benefit they offer compared to traditional heating systems. So low emissions, heat pumps don't rely on burning fossil fuels directly like oil or gas furnaces do. Instead, they're transferring heat using electricity, and because there's no combustion, this results in significantly lower on-site emissions. For homes that previously relied on propane or heating oil, switching to a heat pump can mean a drastic reduction in carbon footprint. Clean energy, the good news is the electric grid itself is getting cleaner every year. Utilities across the country, and especially in Pennsylvania as well, they're shifting towards decarbonized energy sources, such as your solar, your wind, and hydropower. Pennsylvania's primary climate action plan is set to, or it specifically calls for reducing the greenhouse gas emissions, which means the electricity heat pumps, that the use of them is becoming cleaner over time because they're using cleaner energy as well. So that creates a multiplier effect as the grid gets greener. And then refrigerant emissions. That said, we can't ignore refrigerant emissions, which is also contribute to a system's environmental impact when refrigerants leak. Even in small amounts, they can have a strong global warming effect, depending on the type used. That's why the industry is investing in new technologies to minimize leaks through better system designs. We're going to talk a little bit about some of the new systems. There's a new A2L refrigerant system that's out. It was just recently introduced. So they have a lower global warming potential. They're more environmentally friendly as well, which factors in. So installation and maintenance. When it comes to heat pump performance, proper installation is absolutely essential. Even the highest rated, most energy efficient equipment won't perform to its potential if it's not installed correctly. So one of the most important installation aspects is ensuring that the entire system is designed and sized appropriately. That includes the ductwork, airflow, electrical connections, refrigerant lines, all of it. Any misstep during installation can lead to reduced efficiency, poor comfort levels, and even premature system failure. In addition to system setup, we have to consider the building envelope. Insulating to code or even above code and sealing air leaks will drastically improve overall system performance as well. Think of it this way, you wouldn't buy a top of the line heat pump and then leave the windows open all winter long. Yet that's essentially what can happen in some homes if the building envelope isn't insulated properly and the home's not airtight. So be sure to check before, during heat pump installation. Just check the home, check everything to make sure it's efficient and it's installed properly. So talking about installation, the new A2L refrigerants, as of the end of 2024, HVAC equipment is no longer being made using the R410 refrigerant. All equipment is now being manufactured using the new A2L refrigerants. Transitioning to this newer refrigerant is required by the American Innovation and Manufacturing Act of 2020. It's phasing down the use of existing classes of refrigerants and establishes new requirements for refrigerants, conditioners, and heat pumps. The U.S. Environmental Protection, the EPA, they have set transition dates. So residential and light commercial ACs and heat pumps manufactured after January 1st of 2025, they must use the A2L refrigerants. Equipment manufactured prior to this date has a 1-year grace period to be installed. So a little bit about it, the A2L is a more environmentally friendly refrigerant. It's a Class 2L labeled, which is considered lower flammability, whereas the 410A was a Class 1, which was a no flame propagation, is how they were labeled. Two primary refrigerants are being used with the A2L, which is the R454B and the R32. The R54B is a blended refrigerant where the R32 is not blended. So R410 equipment will no longer be sold by the end of 2025, with the exception of only for repairs to existing units. Some refrigerant reviews, they're conducted by the HVAC industry, comparing different types based on performance, efficiency, environmental impact, and safety. Key factors they consider include the refrigerant's global warming potential, flammability, compatibility with existing systems, so on and so forth. Timing for reviewing refrigerants is often driven by regulations. All data shows the next review will be approximately 2032, if not before then. So some minor issues with this transitioning. So the A2L might be slightly more flammable. There's going to be safety controls that will need to be installed, such as leak detection, which, if detected, it will shut the equipment down. Also, an indoor fan will be installed to remove the refrigerant in case it leaks. This will require additional installation with new controls and wiring requirements. Indoor locations will become more critical and require thorough planning. Contractors will possibly need training to understand how to work with the sensors. More maintenance will be needed. Homeowners may not be able to DIY any issues. So if a sensor doesn't work, it's going to shut the system down, and they will most likely need an HVAC technician to take care of it. So those are some issues with the A2L, but moving along. So system sizing, let's talk about this. When planning for a heat pump installation, one of the most important technical steps is completing accurate load calculations. Load calculations, they're going to tell us how much heating and cooling the home actually needs. And it's not just about the square footage. They also have to factor in the level of insulation and air leakage, so which often relates to window size, type, and ceiling, the climate where the home is located. For example, Pennsylvania sees both heating and cooling needs across the throughout the whole year, and home features like ceiling height, layout, orientation, even how people live there or how many people live there. They all impact the system's required capacity. Something that surprises a lot of people, bigger isn't always better. Oversizing a system can lead to short cycling, as I had stated earlier, which means that the system will be turning on and off more frequently, wasting energy. This is why blower door testing is such a valuable tool. It helps to measure how leaky a home is, giving us real data to inform system design rather than guesswork. To make these calculations easier and more accurate, there are some great tools available. So there's the Cool Calc. This is an ACCA approved program that it also follows a Manual J protocol. And then you have the BOPT, that's developed by the Department of Energy, which simulates building performance and helps evaluate energy optimization strategies. So those are all tools that can help ensure that a heat pump is sized properly. Talking about sizing, load calculations. When they're doing the sizing, these are load calculations that would need to be done to meet code requirements. Starting with the manual J load calculation, this determines the exact heating and cooling loads of a building. This step, what it looks like is you have the square footage of the home and the ceiling height. And then you look at the quality of the insulation and the type and size of windows, the sun exposure of the home, including shading and orientation and climate zone, and internal gains from occupants and appliances that produce heat. The goal of the Manual J is to avoid oversizing and undersizing. And then you have a Manual D. This is for duct design. So once the load is calculated, the Manual D is used to design the duct work. If ducts already exist, we verify whether they're sized and laid out appropriately. If ducts are being installed for the first time, the Manual D helps determine the duct diameter, the airflow distribution, and static pressure calculations based on the Manual J output. So properly designed ducts are essential for balanced airflow and occupant comfort. Then we move on to the Manual S, equipment selection. This next step, it matches the calculated loads from Manual J with real manufacturer equipment data. So this step ensures that the heat pump or HVAC unit is sized correctly based off the calculations. And then you have energy calculations. Finally, at the end, many energy codes, including the Pennsylvania UCC, require proof of compliance through energy calculations. These include verifying that the building envelope and mechanical system meet minimum energy or efficiency standards. So that's looking at all the ratings that we had talked about prior. So why does size matter for a heat pump? Heat pumps are measured in either tons or BTUs per hour. So just as a reference, 1 ton of heating or cooling capacity equals 12,000 BTUs. So a 3-ton heat pump can deliver about 36,000 BTUs under rated conditions. So the goal here is, when sizing a heat pump, is to match the system's capacity with the building's largest heating or cooling load. What happens if the system is too small? If it's too small, it may struggle to maintain comfortable indoor temperatures during extreme weather, especially during cold snaps in Pennsylvania. So you want to make sure that it's sized just right. If it's sized too large, then you have problems with short cycling, where it's heating or cooling too quickly, and the system will be turning on and off too quick, which can lead to issues with the system itself down the road. Maintenance, you want to consider maintenance. Regular maintenance is essential. Very important. Filter replacement. They suggest to replace the filters or check them at least every 1 to 3 months. This is something you could train the homeowner. They can do a little bit of upfront work checking this on their own, but it's essential that at least once a year, there are data or there are specifications where they do recommend an HVAC technician should maintain the system every spring and fall, but at least if they're checking it once a year to check for refrigerant levels or any tune-ups, regular cleanings are essential with the system to keep it running properly as well. Some Pennsylvania residential heating statistics. I know I'm getting close to time here. Sorry, I thought I'd finish early. So taking a closer look at heating fuel usage and cost trends across Pennsylvania, they can help to better understand the practical implications of switching to more efficient systems like heat pumps. Heating fuel efficiency comparison here, heating oil systems consumed 58.5 million BTUs is what the data showed. And this data all came from PA Energy ratings of 2025. Natural gas, they showed, used 56.6 million BTUs. Propane used 35.7. Electrical systems, they showed, used 8.5. So with the trends, they're showing approximately 26% of homes in PA use electric heating systems with an average annual heating cost of $412 per year. On the other hand, about 52% of homes use natural gas heating with a higher average annual heating cost around $645 is what the data is showing. So in conclusion of all of this, as I wrap up, heat pumps are highly efficient. They're flexible, they're sustainable. They have sustainable heating and cooling options, especially for Pennsylvania in our varied climates. Whether we're talking about air source, ground source, or ducted mini splits, the key is selecting the right system for the home that it's going to be installed in, for the client and the regional demands. We explored how proper sizing and installation based on manual JD and S calculations, they can make or break performance. We looked at the impact of energy ratings, ductwork installation, maintenance, all of that, how all of it goes into shaping both comfort and energy bills, better energy savings down the road. So we also examined cost ranges. We looked at those. And finally, the big thing is just looking at it's environmentally friendly. So we discussed the role of heat pumps playing in reducing, or how their play reduces emissions, aligning with our climate action plan, and how low GWP refrigerants and improved technology are making these systems even more environmentally friendly. So thank you for joining.